Just looking at timing, all things. Yeah. We're almost on time.
But the first speaker will be Lipsy.
All right, welcome to Wei. So Wei will present a perspective from NOAA on operation model and the need for data simulation.
So thanks for a good introduction, Tom, both Toms. So I am representing the Ionospheric group from NOAA Space Weather Prediction Center today. And obviously there are a lot of other work that we're doing at subsea, not just the ionospheric thermosphere. We're trying to use ensemble approach for a lot of solar observations into our models. We're also looking into how we can improve the satellite radiation and even the aviation level of radiation using the real-time data. So we're just going to cover the ionosphere and thermosphere, and I have Adam Kuberik with me today. I think Tim Fullero is online as well, so we can have some more discussion later on. So I have been showing this every conference I go, and the whole point is let you know what we are working on, right? So this is the only thing right now I'm focusing on. There's no other thing I'm worried about more than this few things in subsea right now. So we are worried about HF communications. So that we want to understand when and what conditions the lower frequency can be utilized for the HF communication, right? So 3 to 30 megahertz, the HF band. And we also want to capture the maximum usable frequency that can be utilized after the storm. Typically, after the storm, the negative decrease of the ionosphere will decrease the usable frequency for the MUF. And then we also want to know how the undulation of the bottom side of region look like. That's where we want to use the ground-based observations, which can capture the things in the bottom. And with satellite positioning, navigation, and timing, and communication satcoms in those frequency L-band, S-band, various structures in the ionosphere in small structure. We're talking about kilometer-wise, 100-kilometer-wise of frequency density changes can interfere with the frequency being used in the system. Larger scale ionosphere can also cause the delay in the ionosphere and cause the signal delay. So there are several structures in the ionosphere we want to capture, and a lot of that does require a detailed data simulation system to capture the changes in the regional sense. And we also look into the satellite drag. So density and uncertainties for decision-making, maneuver planning, orbit keeping, and collision avoidance are pretty critical for it now with the increasing number of spacecraft in space. So I don't have data simulation background, and my team has some info. We are using a lot of the lower atmosphere data simulation in our system, but we have no data currently implemented in our physics-based model that Tom was showing, the WAM-IPE, but we do have other systems that we're currently using data in the system. So the first one I want to talk about is the GlowTech. This model actually just got released publicly last week. We have been running this model for 2 to 3 years to support the aviation industry with a certain threshold for ICAO advisory. And this model actually utilizing the IRI as a background and doing the nowcast. So what had been ingested into the systems are the ground-based GNSS receivers. We have 400 to 500 stations on the ground. We're working with JPL to make sure they can cover us as about 60 to 70 ground-based receiver as a government backbone services. So we are in process of getting that insured. At the same time, we're using all the RO data from Cosmic 2, and RO data is also, the Cosmic 2 is confined in the lower latitude region at this point. We also have a version running in sort of with 2-hour latencies to ingest all the commercial data for the data buy evaluation, commercial data buy. So getting all this data in, we can capture the TEC changes over the globe. But since it's a 3-dimensional density model, we actually can get the vertical profile of things, but we don't have a huge confidence since a lot of signals are integrated from the ground to the GNSS receiver. So this is just an animation showing the storm days, and then you can see that there are a lot of changes in American sector, right? When the storm happened, you can see the gradient. I think the animation will come back. But you can see a lot gradient in American sectors, and I'll show you some of the impact that we were working on. And the other model that Tom mentioned is the WAM-IPE, which is developed and operated by my group. at subsea. So it's an extension of weather model from the ground all the way to 600 kilometers and coupled with the plasma structures. So this model was built about on top of a global forecast system that we're using for the weather model. And right now I'm going to talk a little bit about FV3 that we're going to move into in the future. And this model including lower atmosphere weather and dynamics and all the processes in thermosphere, ionosphere. And what, like what Tom mentioned, that we actually don't have the feedback from the ionosphere back to the thermosphere right now. Thermosphere model, WAM itself can run as a standalone version of model. So WAM provide the three-dimensional density, temperature, and major species. And the ionosphere IPE version will provide the ionosphere and plasmasphere density and velocity and temperature as well. So we have been operating this model since July 2021, and we did some modification last summer. There are 2 ConOps currently running, and you can get the data, you can get the plot in our website, and there are other products that we have developed in the past year. There are 2 ConOps. So why do we need 2 ConOps in running our model? Because space weather change fast, right? So first ConOps is what you're probably more familiar with, the troposphere weather. We have lower frequency data drive. So we run the model every 6 hours, and every 6 hours we do 2 days forecast based on that 6 hours. And we do have the WDAT system implemented in the model, and including the GSI with as well as IAU in that particular first 3 hour cycle, so that we can get data simulation into our system, for the WAM can be updated. And the model is running by the real-time portion of the model is running by 1 minute solar wind parameters, as well as F10 for that day. And then into the forecast portion of the model, we're using F10 and KP forecast provided by subsea for the ConOps. And we realized that because when we implemented the first model, we only have ConOps 1. However, we recognize that the storm behave is very rapid. So when we have a storm hit, ionosphere can respond within 10 minutes, and thermosphere can respond, and you see density increase that impacts satellite within an hour. So it's very important to have a high frequency model running in real time. So ConOps 2 is actually targeting to that. So we are running the model constantly all the time in real time. And then we're trying to, and we get the best data simulation output of WAM from ConOps 1 to drive the ConOps 2 every 6 hour chunk. So in our data release, we have both ConOps in all the parameters in 5-minute cadence for 2-dimensional parameters and 10 minutes for 3-dimensional parameters. So there are a lot of impact that the ionosphere we talk about, right? And actually my group is personally trying to figure out how the impact look like, because any scientist can always say there's impact on PNT, but when and how? And how does it interfere with the algorithm that developed by the GPS receivers companies? So we're working with them. So this is just one example. We are working with FAA on the WASP system. So WASP system is the satellite infrastructure that they use the satellite communication to downlink or directly passing that correction of a GPS receiver on the error caused by the ionosphere to this aircraft in real time. So WASP system provided by FAA has been constantly doing that job. And I didn't know that actually a couple of years ago when we started interact with airlines, we realized that not every company buy it. So not every company has WASP system covered for their GNSS receiver. And this past 2 years, I started to hear more of the vertical landing issues on the US airports because they are taking away the traditional landing systems. So GNSS landing will become a dominant infrastructure, not just in US, as well as in Europe. So GPS issues is become big. And GPS issues is big, ionosphere can impact GPS signals. However, there's more jamming, spoofing, and RFI issue we can't even mitigate at this point. So I think it's a wide variety of issue we're trying to deal with. So in this plot, you can see that the blue one shows that the WASP coverage is in good shape, above 85%, all the way to 100% on the blue area that you can, all the airport in those regions can use this WASP system. And the right side, you can see that during the storm, and if you see some of this very sharp gradient in ionosphere TEC, you can start to see some of this degradation in that signals. And we also work with WASP during the May storm, and we can see that before the day of the storm, the whole day average of the WASP coverage, this is like a vertical accuracy near the airport. For May 9th is in a good shape. Everything is covered and almost 100% availability is there. And May 10th, the average drop down below 85%. And that lasts for 2 days. So both of the days you have very scattered and limited usage of that WAS system. And then it finally get back around 12, you can start using that system again. So we are working with WAS closely and see how the GlowTech model that we produce might be able to support them in real time. They have been using our model to go back and check different events in the past years. And on top of that, we're working with GNSS manufacturers. We're working with several companies together to figure out where our next step for ionosphere simulation product. So we're trying to use ROTI and working with Boston College to transfer ROTI to S4 index, because a lot of times they want to know the threshold, they want to know the index. And we're also working on getting the GPS receiver ground-based to make sure we have those data, right? Currently, our GlowTech is running with free data. Free data means it can go away anytime. So it's kind of crazy that we're running ops systems with ground-based data that is not guaranteed. And within National Weather Service, we're also trying to build up a ground-based systems, including Inoson, kind of rebuild that Inoson capability back so that everybody can use for free. So there are some plans, but going slowly, and we're hoping that will actually come back to support our real-time system. And obviously Cosmic 2, I think John gonna talk a little bit more from the Cosmic office. They're working very hard on producing different product, all clear geolocation, bubble map, and limited disk to support the wide spectrum of the need that we are supporting. So we also do the density product. I mean, density issue was always an issue, and we know about it, but 2021, 22, when Starlink actually lost their 38 satellites, and it get a lot of attention. And since then, we start working with Starlink, trying to make sure they know when the storm comes. They know when they launch into the environment is the right environment they're working on. And it's been like 3 years since we work with them. And because of working with them, we get all the satellite industry to come work with us, including the ground tracking companies. So we start releasing our WAM density in last April. And based on currently, we can access all the neutral density in real time for both ConOps. And I know several companies are using this product to develop next step product for, I don't know, they're selling somebody, but there are also a lot of companies using that to scope out their flight altitude. So this is showing the animation for the May storm. We did have hiccup during the storm. We were getting a call because the model was having issues, and there are certain setup that we thought would never reach there, and we have a hard stop in the model. So the model stopped working. We reduced time step, is not able to mitigate that. So we rerun the event, and we are in process of releasing new version of model. But we quickly fixed all the problem within 2 weeks. So all the data from our AWS bucket should be valid after 2 weeks of the storm. So in this animation, you're going to see the density in the contour plot and the wind velocity in an arrow. And the arrow is very big, and I also have no way to validate at this point because we have very little density measurements. We have no wind measurements in real time right now. So that's a problem, right? When you talk about data assimilation, where's the data? Do we have the data to play with? I have zero data in real time in density right now. I have zero data in wind in real time right now. So how do we do data simulation when we have no data in real time that can support the need? So I'm going to show you this animation. The storm hits about 18 UT. You can start seeing that very big density bulge coming from the high latitude through a joule heating. So heat up the thermosphere on top and all the way propagate through the gravity wave process. You can see that we start getting a more than 1 kilometer, 2 kilometer wind per second. And those winds can be important for the satellite orbit propagation. But the industry also tell me they don't know how to do it at this point. So I think there are a lot of engagement we're working on, really understand how to use the model, how to improve the accuracy of the model, and how do we interact with the industry. So there are a lot of widespread of impact from satellites. Not just the drag problem, right? The radiation problems. There are also like Starlink like to launch into low insertion orbit. So how do they fly safe? And they did launch into a storm 2 weeks ago, and they did so well in 270 kilometers. So I think they're improving their satellite infrastructures and the way how they operationalize the system as well. So during the storm, when everybody's watching Aurora, we're busy, right? Subsea is talking to the power grid company, talking to White House, talking to we actually have to talk to FEMA as well. And my job is talking to the satellite industry. So I will get email from people talk about radiation. And the radiation impact is very, very minor for this event. I have no report from geo orbit on this event. I also have zero impact on the a lot of the LEO orbit. So we are trying to provide the best and accurate real-time information to these companies and trying to make sure they're not being severely impacted. And after the event, we do survey. I mean, their altitude control issue, their orbit, their difficulty in orbit keeping maneuvers. There are problems in they have to rapidly changing the collision avoidance procedures so that since you don't know what density look like and real-time density might not be accurate as well, and the forecast density probably wrong. So you got to quickly change that procedures. And we see this like large constellation like Starlink are reacting really fast, and there was no huge risk as they report after the storm. And then since I was saying there's no density, so how do we get density out of it? In the past 2 years, we work, so in the past year, actually, we work with Cosmic 2 Mission Office to actually trying to see how we can use all the GPS data, including the shape and including all the force model from Cosmic 2 in real-time measurements so that we can back the right orbit average densities. So I think we're still in process. We're trying to see when we can get to a point that we can release the real-time data. And we also work with Eric Sutton in the past years, and I think Eric going to talk more on this project. We are using the Starlink data under the NDA with SpaceX to back derive all the density, orbit average density from Starlink. And we have looked at thousands of satellites, several thousand satellites, and we are in process of setting up a CRADA and really getting them to send us real-time data to test it out. So this is the only thing we have, orbit average density. So how do you put in JEDI? How do you see how we go in the future? And I can only believe this kind of data with lower accuracy, with mass data gonna be there in the future, right? We're not gonna launch thousands of satellites just to do accurate measurements. So how do we live with this coarse measurements to do what we can do? Yes, yeah. Oh, yeah, sure.
Yeah, this is really interesting. So you're striking an agreement with just one vendor right now, Starlink, to get and then hopefully use
Yeah,
their positioning to help get infer the drag and the density. Or
right.
the density.
Yeah,
through
I
the-
will not call them vendor. They're giving everything for free using their own resource. So it's
Oh,
not a
okay.
commercial.
Yeah, I've been involved in these before.
Yeah, I'm confident they'll continue providing for free.
Well, yeah, because it's such a big unknown. Yeah.
Mhm.
And just this one vendor, none of the others so far? Well,
No,
let's talk
because-
offline.
Sorry?
We can probably talk offline.
Yeah, yeah. I know there are other company are trying to sell it throughout the data buy program. But I think working with Eric, I know there are a lot of details need to be thought through, and I'm
Free is
not
good.
super confident that we can buy data but we got to expand that and see. But ultimately, okay, my thinking is there. I don't know, Eric can say more about this. Ultimately, in the future, we have to use free data that is openly available to do this job, right? This is a lot of work with SpaceX itself, and they're giving us things that they don't want to share with the world. So this is a great start, but how do we push the satellite industry to give us what we need that they're willing to share that we can use in different altitude? Because ultimately, I only have a couple of altitude range for this thing, right? And yeah, Project Kuiper is coming up. Once they launch 3,500, we'll have 3,500 different altitude, and I think they will be interesting to share the data for free as well. However, that have to deal with small business problem, right? So small business will come in, won't have money. So we got to figure it out how to do this job. And next step for our model development is we'll continue improve the WAM data, WAM IP actually, a DA system. And we got to improve our ConOps, right? Whatever data we can use, we're trying to drive the model with the real-time EUV as well. So there are a lot of development going on by the model itself. So my intention is I don't need to take care of data assimilation system in my model when I have to put different data with different data assimilation system because my team take care of the model, right? So if we can develop a framework, just like UFS, when we put model in the UFS, you guys can figure out how to do the data assimilation outside the model framework. I think that's ideal for the group like us. And we're developing the drag model, working closely with office space commerce. So office space commerce take the responsibility of the collision avoidance from DoD. So all the commercial collision and NASA collision avoidance will come back to DoD's responsibilities. So working with them and see how we can improve the drag problems with them. And we're working on FV3WAM. This is just a few showcase of where we are. The left figure shows the temperature comparison and zonal wind temperature, zonal wind comparison between our current operational model and FV3WAM. So we're trying to reproduce a version, and we're very close to have a version 1 ready that have sort of the similar capability of current WAM. We're testing the storm capability right now. And right now we are going to put FV3WAM into the UFS framework. And you can also see there are several comparisons for different species that currently going on. So I think several development. We're also trying to secure more analysis signals from the commercial entities. You know, there are a lot of data on your phone. There are a lot of data on spacecraft. How do we use those data, right? So how do we not rely on the ground-based infrastructures, but those things move fast. Those things are not there all the time. So we are working with, we're actually working with Google on some of the phone signals, trying to put it into our system as well in the future. So back to this slide, just want to ensure you that we're working our best to get things done. But operation is very different from research because we have to guarantee real-time capability. We've got to guarantee model perform and doesn't crash like what we had before. So that's all what I have. Thank you. Any questions?
Going to move on to the next speaker and save questions for the discussion period if just to keep on schedule a little bit here.
Yeah, so our next speaker is Irfan Azim.